Hey guys, so this is our very last topic. We are going to use partial fractions to integrate. Mrs. Blodgett did tell me you learned this last year. She thinks you learned it, so we'll see if you remember it as we go through. Okay, so we have no way of integrating this because we can't do a u substitution because there's no x on top. So to do this, what we have to do is break this up. So let's focus on we're just going to focus on the function, which is 1 over, this is, if you factor it, x minus 2, x minus 3. So one topic that is kind of avoided, we always do a topic going one way and then we do the other. And this is one that's it's pretty challenging. So you talk about in Algebra 2, if you have something over x minus 2 plus something over x minus 3, like how to do that, going backwards is a lot harder. So remember, the way that you do this is you have your common denominator. Oh, why are you moving? No, stop moving. Walk. Okay. Hopefully it stops. All right, x minus 3. So what we do is we end up multiplying this left side by x minus 3, and then the one on the right by x minus 2, x minus 2. So that means the numerator, a times x minus 3 plus b times x minus 2, has to equal 1. So the way we do this is we use just guess and check. So I'm going to start by letting x equal 3. If x equals 3, this first term is 0. So I end up with b times 1 equals 1. So that means that b is 1. Right? And then I'm going to do x equals 2. If x equals 2, then I have a times negative 1. And then the second one is 0 equals 1. So that means that my a is negative 1. So I just was able to rewrite this function. So I'm going to come up here and erase this. Why won't you erase for me? There it goes. Okay. So now this function is the integral of a is the first one, negative 1 over x minus 2 plus 1 over x minus 3 dx. So what is the antiderivative of that? Well, that's an ln. So negative ln x minus 2 plus the ln of x minus 3 plus c. So these are always have those ln's. So that's the process. All right, so pause the video, see if you can do this one on your own. So again, we have our x plus 5, so a over x plus 5. I'm going to skip. And then b over x minus 5. And I want that to equal 4 over x plus 5, x minus 5. So the left function, the a, has to be multiplied by x minus 5. And b is being multiplied by x plus 5. So a times x minus 5 plus b times x plus 5, we need that to equal 4. Right? When we put all that together, we need it to be 4. So I'm going to start with x equals 5. So the first term with the a cancels, and we're left with 10b equals 4, which means b is 2/5. And you will notice a lot of these are fractions. Then I'm going to let x equal negative 5. This means the b cancels out. Negative 10a equals 4, which means a is negative 2/5. So I'm going to rewrite this as a goes first, so negative 2/5 over x plus 5. Really pay attention to what goes with what. It's really easy to switch those up. So the antiderivative, negative 2/5, the ln of x plus 5, plus 2/5, the ln of x minus 5, plus c. That's the answer. So it's not hard, it's just a little bit of a process. All right, pause the video, try this one on your own. Be wary of the other x. All right, so I have a over x plus 2 plus b over x minus 4 equals 3x. All right, so I have a times x minus 4 plus b times x minus 2 plus 2, equals 3x. This one's going to be a little weirder. Start with x equals 4 to make the a disappear. That gives me 6b equals 12. So b equals 2. Then I'm going to let x equals negative 2, which will make b equal 0. So negative 6a equals negative 6. So a equals negative 2. So remember, you have to plug into that the right side also when there's an x there. All right, so we get negative 2 over x plus 2 plus 2 over x minus 4. Antiderivative, negative 2, the ln, x plus 2 plus 2, ln x minus 4 plus c. And you actually can, like, you can put that together. Because plus is times, so we could do some weird, crazy things with that if you wanted to. I'm too lazy to do that, though. All right, so now this is the hard one. So the fact that we have something squared will change things. We need to turn this into a over x plus b over x minus 1, and then c over x minus 1 squared. I don't remember why. I'm not even going to lie, you guys. If you want to look it up in the book, look it up in the book. I don't remember why you have to do that, but I just know that you need to do x minus 1 to the first power and x minus 1 to the second. If it was to the third, we'd need to do it 3 times. All right, so now this one's more complicated because, so this a, we're multiplying times x minus 1 squared. B, we're multiplying times x minus 1, because remember, we're finding a common denominator. And the last one, this c, is just x. So we have a x minus 1 squared plus b x minus 1 plus cx equals 0, equals 1. Just kidding. All right. So I'm going to start with x equals 0, because that makes my b and c cancel out. So that leaves me with a equals 1. And then let's let x equal 1. So there a and b cancel out. C equals 1. Now the last one, you kind of have to just pick a number. And we're also going to have to use the fact that we got those. So I'm going to say x equals 2. So we're going to do a is 1 times 1 plus b times 2 times 1 plus c is 1 times 2 equals 1. So we get 2b plus 3 equals 1. 2b equals negative 2. B is negative 1. So we had to actually plug into the entire equation, including the a and the c, to figure the last one out. So that makes these more complicated. So I have, let's see, a was 1, so 1 over x, plus b was negative 1, and then c was 1. Now, this one's a little more complicated when we're finding, I'm running out of space. All right, so the antiderivative of 1 over x is ln of x plus negative ln of x minus 1 plus, now this one, be careful, that's not an ln. That's negative 1 over x minus 1 plus c. So that whole thing is our answer. So a lot more complicated when you have something squared. All right, I don't feel like doing this one. We'll do that one tomorrow. All right, there's your homework. Have a fabulous day. Talk to you tomorrow. Bye.